Welcome aboard the interstellar starship Genesis. Together, we'll journey beyond the boundaries of known space, explore distant worlds, and witness the quiet wonders of the universe. If you enjoy relaxing sci-fi sleep stories like this, please consider liking this video and subscribing to join us on future voyages. Now find a comfortable place to rest. Take a slow, gentle breath, and whenever you're ready, let the journey begin. Chapter 1. The planet was alive. The planet looked completely dead from orbit. There were no lights on its surface, no structures, no transmissions. Nothing suggested that another civilization had ever lived there. And yet, before we left that world, we would confirm something humanity had spent centuries wondering about. It was alive. The evidence would be microscopic. It was nothing we could see from orbit, and nothing that announced itself when we first approached the surface. We found it because something in the planet's atmosphere did not make sense. Months earlier, Genesis had encountered an enormous artificial structure drifting between the stars. It had been built by a civilization that had reached interstellar space long before humanity. The structure contained a record of that civilization's history, along with astronomical references to worlds and star systems that had once been important to them. One of those references had led us here. Astrometry had reconstructed the ancient stellar position and matched it against the sky we could observe today. The star was real, its planetary system was real, and one of its worlds was worth investigating. Navigation brought Genesis into orbit. From the bridge, the planet filled the forward windows. It was smaller than Earth, with a thin atmosphere and broad regions of exposed rock. Dark clouds moved slowly across a pale surface. Large areas appeared completely barren. There were no oceans that we could identify from our first orbital observations. There were no forests. There were no visible signs of civilization. If anything had ever lived there, it had left no obvious trace. The first atmospheric readings arrived while navigation was completing the orbital survey. Several chemical compounds were present in unusual concentrations. None of them proved that life existed. A planet could produce complicated chemistry through geological processes alone. Volcanic activity, radiation, and interactions between the atmosphere and surface could all produce unexpected compounds. So we did what we had learned to do during our investigation of the ancient structure. We tested the observation before assigning it a meaning. The atmospheric data was processed again through Genesis's analytical systems. Navigation compared the readings with the planet's position and orbital conditions. Engineering examined the sampling equipment and verified that the instruments were operating within their expected tolerances. The readings remained. Life support evaluated the atmospheric composition and determined what it would mean for a controlled surface mission. The atmosphere was unsuitable for direct exposure, but there was nothing in the initial data that prevented us from landing with protective equipment. Hydroponics provided another useful comparison. Some of the chemical relationships were familiar from biological processes on Earth. That did not mean the same processes were occurring here. It simply gave us another possibility to investigate. The shipboard intelligence compared the measurements with the geological and atmospheric models we had built from our observations. The result was not an answer. It was a problem. The chemical imbalance appeared to be persistent. Something was maintaining it. We didn't know what. The original plan had been to observe the planet from orbit, record what we could, and continue toward the next location, identified in the ancient records. That plan changed when the repeated measurements gave us no satisfactory geological explanation. A landing would allow us to sample the atmosphere and surface directly. Navigation calculated a descent corridor toward a region where the orbital data suggested the strongest chemical anomaly. Engineering began preparing the landing vehicle. Life support verified the environmental requirements for the crew. The exploration equipment was checked and prepared for surface sampling. No one aboard Genesis said that we had found life. There was still no proof, but there was enough evidence to justify looking closer. The landing vehicle separated from Genesis. The planet grew rapidly across the forward windows as we descended. Rock rose beneath us. Clouds moved slowly across the horizon. There was nothing visible on the surface. No movement, no vegetation, no structures, nothing that looked alive. The landing vehicle touched down. The engines shut down, leaving only the quiet vibration of the systems keeping us alive. For the first time, the crew of Genesis stood on a world beyond Earth, where we had no reason to believe anyone had ever stood before. We had come looking for an explanation for an atmospheric anomaly. We had no idea that the answer was already beneath our feet. Chapter 2. The search begins. The surface was quieter than it had appeared from orbit. Our landing site was a broad field of dark rock surrounded by low ridges. Nothing moved across the landscape. There was no vegetation, no visible water, and no sign that anything had ever lived there. For the first few minutes, we simply monitored the environment. Life support continued sampling the local atmosphere while the exploration equipment established the conditions around the landing vehicle. The atmosphere was thin and unsuitable for unprotected exposure, but the readings remained stable. That allowed us to begin the search. The first samples came from the ground immediately around the landing site. They were collected into sealed containers and transferred to the landing vehicle for analysis. Engineering had established the sampling system before the descent, and its isolation procedures were important now. If we were going to search for life, we couldn't risk finding something that had come from Genesis instead. The first results showed familiar elements in unfamiliar proportions. The rocks contained minerals we recognized, but their composition was different from anything we had encountered on Earth. Then we found water, not an ocean, not a river. Small amounts were trapped beneath the surface and within shallow depressions where the temperature allowed it to remain liquid for limited periods. That changed our priorities. The atmospheric anomaly could still have a geological explanation, but now we had evidence of an environment where chemistry could remain active for much longer than we had expected. The onboard intelligence compared the surface measurements with the atmospheric observations collected from orbit. The two sets of data were consistent. Whatever was affecting the atmosphere appeared to have some connection with processes occurring near the surface. We needed more samples. Navigation used the orbital survey to identify several nearby areas where the atmospheric readings had been strongest. The exploration team moved toward the closest one. The terrain gradually changed as we traveled. The rock became darker, and the surface contained patches of material that looked different from the surrounding deposits. Engineering examined the terrain before we crossed it. There was nothing mechanically dangerous, but the uneven surface made the route slower. We collected samples from several locations and returned them to the landing vehicle. The first results were disappointing. The chemistry was unusual, but nothing required a biological explanation. That was important. We couldn't decide that every unexplained result was evidence of life. The geological explanation remained possible. So we continued. Then one sample produced something different. The analytical system detected a repeating chemical pattern within the material. It was subtle enough that we initially suspected the instrument. Engineering checked the sampling equipment and repeated its calibration. The result remained. A second instrument examined the same sample. The pattern appeared again. That still wasn't proof of life, but it was no longer reasonable to dismiss the result as an equipment problem. We returned to the location where the sample had been collected. The pattern was strongest in material taken from an area where traces of water were present. We began looking for other places with the same combination of conditions. The search led us toward a shallow depression between two low ridges. From orbit, it had looked unremarkable. From the surface, we could see that it was different. The ground was darker there. Moisture had collected beneath a thin layer of mineral deposits. The temperature was relatively stable, and when another sample was taken from the edge of the depression, the same chemical pattern appeared again. This time, it was stronger. We still didn't know what was producing it, but we had narrowed the search considerably. Whatever was responsible for the atmospheric anomaly was not simply something we had detected from orbit. It appeared to be connected to a specific environment on the surface, and whatever was happening there was happening beneath our feet. Chapter 3. Beneath the surface. The depression looked ordinary until we examined it more closely. From the ridge above, it appeared to be little more than a shallow basin between two areas of exposed rock. There was no visible vegetation, no movement, only a thin layer of moisture trapped beneath the surface. Yet the chemical pattern we had detected was strongest here. That made the depression our most promising location. The exploration crew established a controlled sampling area while the rest of Genesis continued monitoring the environment. Life support tracked the atmosphere around us as we worked. The composition remained stable, although several compounds were present at different concentrations than they had been at the landing site. That difference mattered. The atmospheric anomaly was not distributed evenly across the region. It appeared to be associated with particular conditions on the surface. We began collecting samples at different depths. The first came from the exposed mineral layer. It contained the same unusual chemistry we had detected earlier. Then we sampled beneath it. The result changed. Several compounds were present at significantly higher concentrations just below the surface. A deeper sample produced the same result. Engineering monitored the sampling equipment as the drill moved through harder material. The equipment was operating normally, and there was no indication that the readings were being produced by the machinery. The deeper we went, the stronger the chemical relationship became. The onboard intelligence compared the new samples with the atmospheric measurements from orbit. The correlation was becoming difficult to ignore. where the subsurface material contained higher concentrations of the unusual compounds, the atmosphere above it showed a corresponding change. We still had no evidence of life, but we were beginning to understand where to look. The exploration crew followed the depression toward its lowest point. The surface became softer there. A thin layer of moisture had collected beneath mineral deposits, protected from the dry conditions above. We collected another sample. This time, the analytical system detected something we had not seen before. There were microscopic structures within the material. At first, they were too indistinct to identify. They could have been mineral formations. They could have been the result of chemical reactions we did not yet understand. So we changed the method of analysis. A second instrument examined the same sample. The structures were still present. Another sample was taken from nearby. They appeared again. That was when the possibility became difficult to ignore. Something was forming structures in this environment, but formation alone did not tell us whether they were alive. We needed to know whether they were changing, whether they were responding to their environment, whether they were doing something that chemistry alone could not explain. The exploration crew collected samples from several points around the depression. Some contained the structures, others did not. The difference was important. The structures appeared most consistently where moisture and the unusual chemistry occurred together. We began comparing those locations with the environmental measurements. A pattern was emerging. The structures were not randomly distributed across the surface. They appeared to be associated with a narrow set of conditions. For the first time since landing, we had a specific possibility to investigate. There was something beneath the surface. We still couldn't call it life, but we were getting close enough to ask a much more important question. What was it doing? Chapter 4. The pattern. The question stayed with us as we examined the samples. What was it doing? The structures were too small to see without magnification, and their appearance alone could not tell us whether they were biological. We needed to observe what happened when their environment changed. The first test was simple. A sample was separated from the surrounding material and placed inside a controlled chamber. Its temperature, moisture, and chemical composition were monitored continuously, while the onboard intelligence recorded every change. For several hours, nothing happened. The structures remained unchanged. That was not surprising. If they were biological, there was no reason to assume that their activity would occur quickly enough for us to observe it immediately. So we waited. Eventually, one of the chemical measurements began to change. Engineering verified that the containment system was stable and that nothing from Genesis was entering the chamber. The measurement continued to shift. The onboard intelligence compared the new data with the original sample and confirmed that the change was occurring within the material itself. We tested another sample. The same relationship appeared. That result gave us something we could investigate, but it still wasn't enough to call the structures biological. An unfamiliar chemical reaction could produce similar changes. So we changed the conditions. One portion of the sample remained in the environment where we had collected it. Another was placed in a controlled chamber where the moisture had been reduced. The difference appeared slowly. The sample that retained moisture continued to change. The other became almost completely inactive. We watched the measurements for several hours before repeating the experiment. The result was consistent. When the environmental conditions moved outside a narrow range, the activity declined. When these conditions were restored, the activity returned. That was different from simply finding an unusual mineral. Something in the sample was responding to its surroundings. We collected additional material from different depths around the depression. Some samples showed very little activity. Others showed much more. The strongest results continued to come from the same damp layer where we had first found the microscopic structures. The relationship between moisture, chemistry, and activity was now appearing across multiple samples. The onboard intelligence compared the results with biological processes known on Earth. There were similarities. The processes were not identical to anything we had studied on our home world, but the underlying behavior was familiar. Material was being taken from the surrounding environment and changed. Chemical conditions were being maintained rather than simply occurring once. And when the environment changed, the activity changed with it. We still had no organism we could see. There was no movement visible to the human eye. There was no recognizable creature waiting beneath the surface. But the evidence was becoming harder to explain as ordinary chemistry. For the first time since landing, we had a testable biological hypothesis. We were not ready to announce that we had found life. We needed stronger evidence, and that meant looking closer. Chapter 5. Something alive. We needed stronger evidence. The results from the previous tests had given us a biological hypothesis, but a hypothesis was not enough. If Genesis was going to record the discovery of extraterrestrial life, we needed to be certain that what we were observing was actually alive. Fresh samples were collected from several locations within the damp layer beneath the surface. The same microscopic structures appeared in each sample. That consistency mattered. We transferred the material into separate controlled chambers and examined it at higher magnification. For the first time, we could see the structures clearly. They were extremely small. Each consisted of a compact boundary surrounding a complex interior. Their shapes varied slightly, and their internal chemistry was different from the surrounding material. The onboard intelligence compared the new observations with the measurements we had already collected. The structures were taking compounds from their surroundings and changing them. Their internal chemistry remained distinct from the material around them. That was significant, but it still wasn't enough. An unusual chemical system could produce results that looked surprisingly biological. Then we observed a change. One of the structures had altered its shape. At first, we suspected movement within the sample. Engineering confirmed that the chamber was stable and that nothing mechanical could have produced the change. A second instrument examined the same structure. The change was real. Then another structure changed. We continued watching. The process was slow, but it continued. Some structures became larger. Others appeared to separate into smaller structures with the same basic characteristics. We followed the process through repeated observations. The changes were not random. They occurred under the same environmental conditions we had already identified as important. When moisture and available chemical energy were reduced, the activity slowed. When those conditions returned, the activity resumed. We collected another fresh sample and repeated the observation. The same process occurred again. That was the point when the evidence crossed a threshold. These structures were not simply present in the environment. They were interacting with it. They were maintaining an internal chemical state. They were changing over time. And they were producing new structures that shared their characteristics. The onboard intelligence compared the observations with the biological processes we knew from Earth. The similarities were no longer limited to chemistry. The evidence was consistent with the fundamental behavior of living systems. We had found life. There was no creature moving across the landscape. Nothing visible to the naked eye had greeted us when we landed. The first life humanity had discovered beyond Earth existed beneath the surface, at a scale that required instruments simply to see it. For a long time, we watched the samples in silence. Humanity had spent generations searching the sky for evidence that life existed somewhere beyond our planet. We had imagined signals, civilizations, and worlds covered in living things. Instead, our first confirmed discovery was almost impossibly small. A few microscopic structures beneath the rocks of a distant world. But they were alive. And now that we knew life existed here, another question became impossible to ignore. Had the civilization that brought us to this world known about it too? Chapter 6. A different kind of life. Finding life was one thing, understanding it was another. The first samples had answered the question we had been asking since landing. The structures were alive. Now we needed to understand how they lived. The exploration crew returned to the depression and collected samples from several depths. The results were not identical. The organisms were most abundant in the damp material beneath the surface, although traces appeared farther into the surrounding rock as well. That suggested they were not confined to a single pocket of water. They were interacting with the environment around them. The onboard intelligence compared their chemistry with known terrestrial microorganisms. The comparison gave us useful similarities, but the differences were just as important. The organisms did not appear to use the same molecular structures that life on Earth uses to store and reproduce genetic information. Their chemistry was unfamiliar, yet their behavior was recognizable. They maintained an internal chemical environment. They took material from their surroundings and transformed it. When conditions were favorable, they produced new organisms. The process was slow. That made sense given the world they inhabited. There was little available energy near the surface, and the environment changed gradually. The organisms appeared to be adapted to those conditions. We began testing what happened when we changed their environment. Increasing the available moisture produced a measurable increase in activity. Changing the temperature produced a similar response, but only within a narrow range. Beyond that range, the organisms became inactive. When the original conditions were restored, their activity resumed. The results gave us another piece of the puzzle. These organisms were not simply surviving in a strange environment. They were adapted to it. And that brought us back to the atmospheric readings that had first brought us down to the surface. The chemical imbalance we had detected from orbit was no longer an isolated mystery. The organisms were producing some of the compounds we had measured. Their activity was affecting the environment around them. Not dramatically, not enough to transform the planet, but enough for our instruments to detect from orbit. We had arrived expecting to find an empty world. Instead, we discovered an ecosystem too small to see. There were no forests, no animals, no visible signs of life across the surface. Life existed in the spaces between the rocks, wherever water, minerals, and energy came together, and it had apparently been doing so for a very long time. Then we returned to the astronomical records that had brought us here. Before landing, we had identified this world because the ancient civilization had marked its star system. At the time, we had assumed the reference was connected to their exploration or settlement history. Now we searched those records again. The new information changed what we were looking for. A section of the archive that had previously seemed incomplete contained additional observations associated with this system. There were measurements of the planet's atmosphere. There were references to its surface conditions. And there were repeated observations from different periods in the planet's history. The records were not describing a settlement. They were describing the world itself. The civilization had studied it, and the more we examined those records, the more difficult it became to believe that the planet had been chosen at random. They had noticed something here, something they considered important enough to preserve. We had arrived thinking we were the first to discover life beyond Earth. Now we knew something else. Someone had found this world before us, and they had left a record of what they had seen. Chapter 7. How long has it been here? Finding life had answered the biggest question. Now we wanted to know something more difficult. How long had it been here? The organisms were living beneath only a thin layer of rock, but the environment around them suggested that the system had been stable for a very long time. The geological team began examining the layers surrounding the samples. There were no obvious signs of a recent disturbance. The mineral deposits had formed gradually, with older material lying beneath newer layers. The organisms appeared throughout the same sheltered regions where moisture could persist. That was important. They were not confined to a single accidental pocket. The same biological activity appeared in samples collected from different parts of the depression. We expanded the search. The exploration crew moved farther along the basin, collecting material wherever the surface conditions changed. Some areas were completely inactive. Others contained small traces of the same organisms. The pattern followed the availability of moisture and chemical energy. Where the conditions were suitable, life appeared. Where they were not, it disappeared. The onboard intelligence began comparing the biological distribution with the geological structure of the region. The relationship was surprisingly consistent. The organisms were occupying environments that had existed for a long time. There was no evidence that they had arrived recently. No indication of a sudden contamination event. No trail leading back toward our landing site. The life was part of the planet. It had been living here before Genesis arrived, and the deeper we examined the surrounding material, the older the environment appeared to be. That raised another possibility. Perhaps this was not a young ecosystem adapting to a new world. Perhaps it had been here for an extraordinary length of time. We could not determine the exact age of the organisms themselves. Biology does not leave a simple clock behind, but the geological record gave us another way to think about the question. The layers surrounding the organisms had formed over immense periods. The conditions that allowed them to survive appeared to have persisted through much of that history. There was no sign that the ecosystem had only recently emerged. The evidence pointed towards something much older. Life on this planet had not arrived with us. It had not been created by the civilization whose star chart brought us here. It had its own history, its own environment, its own beginning. That realization changed the way we looked at the planet. From orbit, it had appeared barren. From the surface, it had seemed almost empty. But beneath the rock, an entire living system had been continuing quietly for longer than humanity had existed. Perhaps for far longer. We had come here because an ancient map told us that this world was worth noticing. Now we understood something the map could never have told us. The planet did not need a civilization to make it important. It had been alive all along, and suddenly, every other world we had passed on our journey seemed a little different. If life could exist here, how many other worlds were waiting for us to look closely enough to find it? Chapter 7. How long has it been here? Finding life had answered the biggest question. Now we wanted to know something more difficult. How long had it been here? The organisms were living beneath only a thin layer of rock, but the environment around them suggested that the system had been stable for a very long time. The geological team began examining the layers surrounding the samples. There were no obvious signs of a recent disturbance. The mineral deposits had formed gradually, with older material lying beneath newer layers. The organisms appeared throughout the same sheltered regions where moisture could persist. That was important. They were not confined to a single accidental pocket. The same biological activity appeared in samples collected from different parts of the depression. We expanded the search. The exploration crew moved farther along the basin, collecting material wherever the surface conditions changed. Some areas were completely inactive. Others contained small traces of the same organisms. The pattern followed the availability of moisture and chemical energy. Where the conditions were suitable, life appeared. Where they were not, it disappeared. The onboard intelligence began comparing the biological distribution with the geological structure of the region. The relationship was surprisingly consistent. The organisms were occupying environments that had existed for a long time. There was no evidence that they had arrived recently. No indication of a sudden contamination event. No trail leading back toward our landing site. The life was part of the planet. It had been living here before Genesis arrived. And the deeper we examined the surrounding material, the older the environment appeared to be. That raised another possibility. Perhaps this was not a young ecosystem adapting to a new world. Perhaps it had been here for an extraordinary length of time. We could not determine the exact age of the organisms themselves. Biology does not leave a simple clock behind, but the geological record gave us another way to think about the question. The layers surrounding the organisms had formed over immense periods. The conditions that allowed them to survive appeared to have persisted through much of that history. There was no sign that the ecosystem had only recently emerged. The evidence pointed towards something much older. Life on this planet had not arrived with us. It had not been created by the civilization whose star chart brought us here. It had its own history, its own environment, its own beginning. That realization changed the way we looked at the planet. From orbit, it had appeared barren. From the surface, it had seemed almost empty. But beneath the rock, An entire living system had been continuing quietly for longer than humanity had existed. Perhaps for far longer. We had come here because an ancient map told us that this world was worth noticing. Now we understood something the map could never have told us. The planet did not need a civilization to make it important. It had been alive all along, and suddenly, every other world we had passed on our journey seemed a little different. If life could exist here, how many other worlds were waiting for us to look closely enough to find it? Chapter 9. The First Life Beyond Earth. We'd come to this world expecting to find an empty planet. Instead, we had found life. Not a civilization, not a transmission, not evidence of intelligence. Something much simpler. And somehow, that made the discovery feel even more important. For the first time, humanity had direct evidence that life was not confined to Earth. The organisms beneath the surface were small, slow, and completely unfamiliar. They had evolved under conditions unlike anything we had experienced on our homeworld. Yet they were alive. They consumed material from their surroundings. They maintained themselves. They reproduced. And they had continued doing so for an immense span of time, without anyone from Earth knowing they existed. The exploration crew continued collecting samples while the planet remained beneath us. Each sample was sealed and cataloged. Engineering verified the containment systems before the material was brought aboard Genesis. Life support maintained the environmental conditions required to keep the organisms stable. Hydroponics helped establish controlled environments where their behavior could continue to be observed without disturbing the original ecosystem. The onboard intelligence began organizing the observations into a permanent record. We weren't taking the planet with us. We didn't need to. The data was enough to preserve what we had learned. The location, the environmental conditions, the biological activity, the geological context. Everything we could measure was recorded, because this discovery belonged to more than the crew standing on that world. One day, other humans would study these results. They would question our conclusions. They would repeat our measurements. They would learn things we had not yet understood. That was how science moved forward. One observation became another question. One discovery opened another field of investigation. And now humanity had a new world to study. Before leaving, we made one final survey of the region. From the surface, the planet still looked almost completely lifeless. There was no visible sign of what we had found beneath it. That was something I kept thinking about as Genesis prepared to depart. For generations, humanity had looked toward the stars and wondered whether life existed somewhere beyond Earth. We had searched for signals. We had studied distant planets. We had listened for evidence of intelligence. But our first confirmed discovery had been waiting quietly beneath the rocks of a world that looked empty from orbit. We'd almost missed it. The thought changed the way I looked through the observation window as the planet began to recede behind us. Every distant world we passed had previously been just another destination. Now each one carried another possibility. A world could look barren and still be alive. A planet could hide an ecosystem beneath its surface. And somewhere among the countless stars ahead of Genesis, there could be other worlds we had never considered worth searching. We didn't know how common life was. We didn't know whether this planet was unusual or whether the galaxy was filled with worlds like it. we only knew one thing for certain. Earth was no longer the only world where humanity had confirmed that life existed. Genesis turned toward the next stage of its journey. The planet became smaller behind us. Soon it would disappear from view, but the discovery would remain with us, not as a story about something we had imagined, not as a possibility, as evidence. Life existed beyond Earth, and now, wherever Genesis traveled next, we would never look at another world quite the same way. Our journey comes to an end, for now. Thank you for traveling aboard the interstellar starship Genesis. If you'd like to continue exploring the stars with us, please consider subscribing for future voyages. Until we meet again, sleep well and safe travels.